Hello students, this is a video on the topic test that we at Bodhee Prep have prepared for you for quant. Now, you take these tests once you've covered the basic concepts of a topic, and with every test there is a video which gives you the solutions and a brief analysis of that test in terms of time and level of difficulty. There are more than 200 topic tests available on our Bodhee Prep Android app. The link for the app is in the description below, so download the app and make the most of these tests. This video is on the topic functions, and this is a discussion of the test number 2 on functions. Overall, I think a moderate level of difficulty, 5 to 6 questions net correct, should give you a 95 plus percentile in a test like this. And in terms of attempt time, I think it will be on the higher side, maybe 25-26 minutes, because there are calculations involved. And also, this 26 minutes does not mean that I'm able to solve all the 10 questions. It is about me getting the 95 percentile. That is 5 to 6 net questions correct after accounting for negative marks. If you look at the questions, the first question says, let gx be a function such that gx plus 1 plus gx minus 1 is equal to gx for all real x. What is the value of p in the... For what value of p is the relation gx plus p is equal to gx necessarily true for every real x? So first of all, we'll have to eliminate one of the values from here. So what we can do is we can put x is equal to 1, which gives us g of 2 plus 1 minus 1. G of 0 is equal to g of 1. We can then put x is equal to minus 1, which will give us 1 minus 1. G of 0 plus minus 1 gives me minus 2. G of minus 2 and minus 1. Again, two numbers are missing, so not using minus 1 here. I would want to have two numbers same. If we put g is equal to 0, for example, if I put x is equal to 0, we'll have g is equal to 0 plus 1. 1 plus 0 minus g of minus 1 is equal to g of 0. Two terms are same. If this is equation 1, this is equation 2, and we add them, we will get g2 plus g0 plus g1 plus g minus 1 is equal to g1 plus g0. These two can be cancelled, g0, g1, and therefore we get g2 is equal to g minus 1. The difference between them is 3. Therefore, g of x, if say x is equal to 2, this means subtract 3 on both sides, x minus 3 will be minus 1. So g of x will be equal to, this will be negative because we are taking on the right hand side, minus of g of x minus 3. Or rather, if we, since we need a plus on the other side, if we put minus 1 as x, if x is equal to minus 1, adding 3 on both sides, you get x plus 3 as 2. So here we can write g of x plus 3 is equal to minus g of x. We have a situation similar to this, but the point is both of them were positive values. Again, substituting x by x plus 3, we can get g of x plus 6 is equal to minus g of x plus 3. From here, we can write minus g of x plus 3 multiplying by minus is equal to g of x. So minus g of x plus 3 is equal to g of x. It is equal to g of x plus 6. Therefore, g of x plus 6 is equal to g of x becomes my expression, and therefore p will be nothing but 6. Option D. I will actually call this a question, probably an easy question, because process is standard. If you have gone through all questions on functions, you would have come across similar questions, and all you have to do is repeat the process. Therefore, easy conceptually, the attempt time might go up to 2 to 2.5 minutes. A function fx is defined for all real values of fx as fx is equal to x minus 1 upon x plus 1. So y1 is f of x, y2 is f of x, and so on iteratively. We have to find the value of y501. So y1 simply is x minus 1 upon x plus 1. Y2 will be f of x, which is x minus 1 upon x plus 1. So if we substitute the value of x as this number, this expression, will get x minus 1 upon x plus 1 minus 1 upon x minus 1 upon x plus 1 plus 1. Substituting this entire thing for x. This becomes x minus 1 minus x minus 1 upon x plus 1 upon x minus 1 plus x plus 1 upon x plus 1. X plus 1, x plus 1 cancel from the denominators. We get minus 2 upon x. This becomes y2. Y3 will be f of x, or we can say this is nothing but y2. So f of y2 iteratively, this is this is y1. This entire thing is y2 and so on. F of y2 will be nothing but f of minus 2 by x. Substituting this value here, we get minus 2 by x minus 1 upon minus 2 by x plus 1. Sorry, not minus 2 by x, minus 2 by 2x will be is what we'll get. And therefore minus 1 by x is what we'll get here. Sorry for the mistake. Put 1 here. Okay. Now it is okay. Minus 1 by x is what we'll get here. So minus 1 by x minus 1 upon minus 1 by x plus 1. This becomes minus 1 minus x upon minus 1 plus x upon x. X and x cancelled. We can multiply by minus 1. So this will become x plus 1 upon this will become 1 minus x. This is y3. Y4, again, we are trying to reach a situation where a term repeats, because from there on we'll get the same term again and again, or the same cycle again and again. This is f of y3. F of y3 will be y3. Replace y3 for x. Y3 is this. So x plus 1 upon 1 minus x minus 1 upon x plus 1 upon 1 minus x plus 1. This will become x plus 1 minus 1 plus x upon x plus 1 plus 1 minus x. In both cases, we have 1 minus x in the denominator. I've cancelled that out directly. This becomes 2x, 1 minus x, minus 1 plus x, plus 1 minus x. Now the signs are correct. This becomes 2x upon 2, which is x. And therefore, if we find y5, y5 will be nothing but f of y4, which is f of x, which is x minus 1 upon x plus 1. Therefore, 1, 2, 3, 4, and then the pattern will keep on repeating. 5, 6, 7, 8, 7, 8. Y1, Y2, Y3, Y4 will take values. Y5 will take the same value as Y1. Therefore, Y6, Y7, Y8 will be same as 2, 3, 4 respectively. Then again, Y9 will be here. Y10 will be same as Y6. Y11 will be same as Y7, Y12, and so on. So before 501, the multiple of 4 is 500. So we can say y500 will be same as y4, y8, y12, and so on. And therefore y501 will be the next term in this line. That is, it will be the same as y1, y5, yn. Y1 is x minus 1 upon x plus 1, and therefore y501 will also be x minus 1 upon x plus 1. Option D becomes the answer. For me, this is a moderate question. Again, the process is simple, but the calculation is long, and it is very easy that a mistake might happen. I ended up making 2 mistakes when solving, and therefore moderate, if not difficult, and the attempt time goes up to 2.5 to 3 minutes easily. Even if you're taking more time to solve it, that is okay, but make sure you don't make a mistake, because these questions are sure shot questions. You will get a pattern in at most six terms. So if we do this properly, it will definitely give us a positive score. How many two-digit natural numbers satisfy greatest integer function x by 9 is equal to greatest integer function x upon 101 plus 1? Where this is denotes the greatest integer function. Now, for any two-digit number, that is 10 upon 101 plus 1, 299 upon 101 plus 1. The right-hand side in all cases, this will be 1 point something, and the last term will also be 1.99 or something. In all of the cases, the value that the right hand side will return is 1. And therefore, what we want is x minus 9 to be equal to 1. For all two-digit numbers, this will be less than 1. 1 plus something which is less than 1 is a value between 1 and 2. For all values between 1 and 2, greatest integer function will return an answer of 1. Therefore, we need mod of x upon 9 to be x upon 9 greatest integer function to be 1 as well. When does this happen? When x is equal to 9 and anything less than 18. In all cases, 9 by 9 is 1. 10 by 9 will also return us as 1 because 10 by 9 is 1 point something. The value will change when x becomes 18. In this case, we'll get the greatest integer function as 2, and from there on, a value greater than 2. Therefore, x can take any value between or from 9 to 17. 9, 10, 11, 12, 13, 14, 15, 16, 17. Hence, the number of options is 9 values are possible, which becomes my answer. Again, easy to moderate question. The moment we realize the right hand side, getting the left hand side is not very difficult. About 2 minutes to solve the question. Fn is defined as 2 raised to power n minus 1 plus 1 where n is odd, n minus 1 minus 1 where n is even. So in this case, if we find F1, F1 will be equal to 1 is odd. So 2 raised to power 0 plus 1, which is 1. If you look at F2, F2 will be, this is even. So 2 raised to power 2 minus 1 minus 1, which will again come out to 2 minus 1, which is 1. If you look at F3, F3 is odd, 2 raised to power 3 minus 1 plus 1. So 2 raised to power 4 plus 1, 5. If you look at F4, 2 raised to power 4 minus 1 minus 1. Minus 1 minus 1. So this will be, if you look at F1, it will be 2 raised to power 1 minus 1 plus 1. So 0 plus 1. 2 raised to power 0 is 1. 1 plus 1 is 2. When we put F2, n is even 2 raised to power 2 minus 1, which is 2 raised to power 2, 1. Here we'll get 5. Here we'll get 5. 4 plus 1. Then we'll get 8 minus 1, which is 7. F5 will be 2 raised to power 5 minus 1 plus 1 because it is odd. So 16 plus 1 is 17. Then 2 raised to power 6 minus 1 minus 1, which is 31, and so on. 2, 1, 5, 7, 17. 4, that should be divided by 127. But instead of finding the value of the terms, we could just work with the general term. Now, if we look at these terms, what will happen is we can take the 2 power terms common. So 2 raised to power 1 minus 1 plus 2 raised to power 2 minus 1 plus 2 raised to power 3 minus 1 till 2 raised to power 100 minus 1. And there will be plus 1s and minus 1s. So 1 minus 1 plus 1 minus 1 and so on 100 times. This will become 0. So here, if we look at it, this is 2 raised to power 1 by 2 plus 2 raised to power 2 by 2 plus 2 raised to power 3 by 2 and so on up till 2 raised to power 100 by 2. Minus 1 means 2 raised to power 100 upon 2. So this term then becomes 2 raised to power 1 plus 2 raised to power 2 up to 2 raised to power 100 upon 2. This can further be written as if we add 1 and subtract 1 plus 2 raised to power 1 plus 2 raised to power 2 and so on till 2 raised to power 100 minus 1 upon 2. This entire term, the first 101 terms can be written as 2 raised to power 101 minus 1 upon 2, and therefore 2 raised to power 101 minus 2 upon 2. This is nothing but 2 raised to power 100 minus 1. Dividing by 2, we get the value. So this expression here equals to 2 raised to power 100 minus 1. We have to divide this by 127. 127 is 2, 4, 8, 16, 32, 64, 120. 2, 4, 8, 16, 32, 64, 128. 2 raised to power 7. Now, if we divide 2 raised to power 100 by 127, this can be written as multiple of 7 is 98. So 2 raised to power 4 into 2 raised to power 7, 14 upon 2 raised to power 2. 127. 7 fours are 98 plus 2. So this becomes 2 square into 128 raised to power 14 by 127. 128 by 127 gives us a remainder of 1. And 2 raised to power 4 gives us a remainder of 2 raised to power 2 gives us a remainder of 4. So 2 raised to power 100 divided by 127 is a remainder of 4. And therefore 2 raised to power 100 minus 1 will be a remainder of 4 minus 1, which is 3. Option A becomes the answer. In terms of level of difficulty, I'd say moderate to difficult level. First of all, getting the expression correct and then finding the division. So clearly two different concepts involved. 2.5 to 3 minutes easily to solve this question. A function fx is defined as x plus 1 into x plus 1 into fx plus 1 plus x into fx plus x minus 1 into fx minus 1 is equal to 0 for x greater than equal to 2. Here, if we look at it, x plus 1 into fx plus 1 plus x into fx plus x minus 1 into fx minus 1 is what we have is equal to 0. If we replace x by x plus 1, we'll have x plus 2 into fx plus 2 plus x plus 1 into fx plus 1 plus x into fx. Replacing x by x plus 1, we get 0. This is equation 1, this is equation 2. Sub 1 minus 2, or rather 2 minus 1 if we do, we'll get x plus 2 into fx plus 2 is equal. This term and this term cancel, this term and this term cancel, minus x minus 1 into fx minus 1 is equal to 0. And therefore, x plus 2 into f of x plus 2 is equal to x minus 1 into fx minus 1. If we substitute x by x plus 1 again, we'll get x plus 3 into fx plus 3 is equal to x into fx, difference of 3 terms. Now, therefore, if I know f1, I can calculate f4, f7, f10 and so on. If I know f6, I can calculate 6, 9, 12 and so on. We are trying to calculate 14. 1, 4, 7, 10, 13, 6, 9, 12, 15, not possible. So for f14, what we can do is, let us try to calculate 6, f5. 5, 8, 11, 14. Now, if you put x is equal to 5 here, we'll get 6f6 plus 6f6 plus 5f5 plus 4f4 is equal to 0. Also, from here we can say if you put x is equal to 1, 4f4 will be equal to 1f1. 6f6 is 6 into 180 because f6 is 180 plus 5f5. 4f4 is equal to f1, which is 40. Therefore, 5f5 comes out to 1080 plus 40, which is minus 1120. Now, putting x as 5 here, we can get 8f8 is equal to 5f5. Again, putting x as 8, we can get 11f11 is equal to 8f8. And putting x is equal to 11 in this equation, we can get 14f14 is equal to 11f11. 14f14 is 11f11, 11f11 is 8f8, 8f8 is 5f5. Therefore, 14f14 is equal to 5f5, which is minus 1120. And therefore, f14 is equal to minus 1120, which will give us f14 as minus 1120 upon 14, which will come out to 14 8s are 112. Minus 80 becomes the answer, option number C. Again, for me, this will be a difficult question because first of all, an arrangement has to be done, and then we are trying to get to a value which is 3 steps forward. Uh, and therefore, while solving, it is very easy to get confused with the values as we start putting them, and multiple equations might get formed. So difficult, easily 3 minutes to solve the question. Because the following could be possible value of x for which each of the fractions, GIF x plus 2 upon 10, GIF x plus 13 upon 11, and so on, is in its simplest form, where square bracket x stands for greatest integer less than equal to x, so GIF function. Now, if you look at the individual terms, they are x plus 2, oh sorry, GIF x plus 2 upon 10. Since they are in simplest form, they should not have any common factor. The next term is, if I divide 13 by 11, x plus 2 plus 1. If I look at the next term, x divide 26 by 12, again 2 is the remainder, plus 2. Again, divide 41 by 13, we'll get x plus 2 plus 3. 13 3 is 49. 13 3 is 39 minus 41 is the remainder of 2. And so on. The last term will be again divided by 50. GIFX remainder 2 plus 40. So basically what we want is GIFX plus 2 should not have anything in common with 10. GIFX plus 2 should not have anything common with 11. GIFX plus 2 should not have anything common with 12, and so on till GIFX plus 2 should not have anything common with 50. If x is equal to 45, GIFX will 45.45, GIFX will return 45. Now 45 plus 2 will have a common factor with 47. So when the denominator is 47, it will not be in the simplest form. We will be able to cancel out it once. This is not the answer. If we put x is equal to 49.49, GIFX will return 49. 49 plus 2 is 51. 51 will have common factors with 3 and 17. 51 upon 3 will not be in the will not be in the simplest form. 51 upon 17 will not be in the simplest form. If we put x is equal to 51.51, GIFX will return 53. 51, sorry. 51 plus 2, 51 plus 2, 53. 53 is a prime number which has no common factor other than 1. And therefore 53 upon 10, 53 upon 11, 53 upon 12, and so on. All of them will be in the simplest form. And therefore this becomes my answer. Putting x as 53.53 gives GIFX as 53. 53 plus 2 is 55. 55 is common factor with 11, so not in the simplest form. Hence option C becomes my answer. I call this question easy question because all you're doing is putting the values and checking. And even if you're not able to break down the term, there are 3 options. There are 4 options. All we have to do is put and check the value. So should not be very difficult to solve. Maybe the attempt time might be a little higher. 2 to 2.5 minutes you might take, but I think in terms of level of difficulty, not difficult, not a difficult question. Fx is a polynomial of the form fx into f of 1 by x is equal to fx plus f of 1 by x. Only f of 3 is given. And therefore, what we can say is f of x into f of 1 by x minus f of x is equal to f of 1 by x. We are trying to get the form of this equation. What kind of an equation will satisfy this? Or what kind of a function will satisfy this equation? So f of x becomes f of 1 by x minus 1 is equal to f of 1 by x, and therefore f of x can be written as f of 1 by x upon f of 1 by x minus 1. If we substitute x by 1 by x, we'll get f of 1 by x as f of x upon f of x minus 1. Substituting x by 1 by x, multiply the two, so f of x into f of 1 by x is equal to f of 1 by x into f of x upon f of 1 by x minus 1 into f of x minus 1. This gets cancelled, and therefore the net equation, the net expression that we get is f of 1 by x minus 1 into f of x minus 1 is equal to 1 from here. Now, if we put a function, say h of x, as f of x minus 1, this means h of 1 by x will be h of 1 by x f of h of x you are putting as f of x minus 1, so h of 1 by x will be f of 1 by x minus 1. So this can be written as h of 1 by x into h of x is equal to 1. Now for a function to satisfy this, we can have h of x as x raised to power n. So h of 1 by x will be 1 by x raised to power n, and as we can see the product is equal to 1, which means from here we can say f of x minus 1 is equal to x raised to power n, which means f of x is nothing but x raised to power n plus 1. Now we know that f of 3 is equal to 28. X is x raised to power n plus 1, so x raised to power, or 3 raised to power n plus 1 is equal to 28, which means 3 raised to power n is equal to 27. This gives us n as 3, because 3 cube is 27. So my net function f of x becomes x cube plus 1, because n has come out to 3. So what will be the value of f4? 4 cube plus 1, which is 65, becomes the answer. Now solving the question, I would say, is a difficult question. Very rarely will you be able to solve it, but in a question like this, if you're trying to do it in the exam, hit and trial might not be a bad idea, because there is just one data point given. Try to reach 28 from 3. You would eventually realize that x cube plus 1 is equal to 28, and then check for options. Again, if you're not able to attempt too many questions, this is something that you might do. Otherwise, solving this question is difficult as far as I'm concerned. For any positive integer n, f of n is defined as n into n plus 1 if n is even, and fn is equal to n plus 3 if n is odd. If m is a positive integer, positive, such that 8 times f of m plus 1 minus f of m is 2, then m equals 2. So what we can do is, let us take m as even. This is case 1. In this case, m plus 1 will be odd, m will be even. So we write 8 of f m plus 1 minus fm. M is even for me here. So m plus 1 will be odd. So this becomes 8 times of m plus 1 plus 3. Fn is n plus 3. So m plus 1 is odd. M plus 1 plus 3 minus m is even. So this becomes m into m plus 1. This comes out to 2. So this is nothing but 8m plus 32 minus m square minus m is equal to 2. So minus m square minus plus 7m plus 30 is equal to 0, which means m square minus 7m minus 30 is equal to 0. 5 2. So m minus 5 into m. So this will not work. The sum of two numbers is 30. 10 and 3. M minus 10 into m plus 3 is equal to 0. Minus 10 plus 3 is minus 7. Minus 7 into 3 is minus 30. So m is equal to 10 or m is equal to minus 3. But m is a positive integer, so this cannot happen. M is even, yes, m is even. So m can be equal to 10. And that should be my answer. I can very well stop here. But I'll just check for m odd as well. If m is odd, we will have 8 times m plus f of m plus 1. M plus 1 will be even, minus fm, which will be odd, is equal to 2. This becomes 8 into m plus 1 into m plus 2, because m plus 1 is even, minus fm, m plus m plus 3 in brackets is equal to 2. So this becomes 8 m square plus 24m plus 16 minus m minus 3 is equal to 2. So 8m square plus 23m minus 3, minus 2, plus 11 is equal to 0. If you look at b square minus 4ac, b square minus 4ac will be 23 square, 529 minus 44, 832, 352. 529 minus 352. From here, we will not get an integral solution because b square minus 4ac is not a perfect square. And therefore, the only solution possible is m is equal to 10 becomes my answer. But since this question is a fill in the blanks and we are looking for a solution, the moment we get m is equal to 10, that should be good enough for us to stop the solution. And therefore, moderate level of difficulty, 2 to 2.5 minutes to solve the question, depending on where we start. If we start with m is odd, the attempt time decreases because we're not getting a solution. If we start with m is even, we'll get the solution and we can stop there. Answer the question on the basis of the information given below. F1 of x is x if x lies between 0 and 1. It is 1 when x is greater than equal to 1 and 0 otherwise. For negative values, it is 0. F2 is F2x is defined as f of 1, f1 of minus x, and so on. Okay. So what we can do is we can take 4 values of x. I am taking minus 4, minus 0 0.2, 0 0.2 and 1. Why these values? Because the value of x changes at negative between 0 and 1 and 1. Also, when we look at f2x, it is minus x. So the uh, answers will be opposite. Minus 4 for f2x will be treated as 4 and so on. So let us take this as 4. So if you look at the value of f1 for these 4 values of x, f of minus 4 will be 0 negative, f of minus 0.2 will be negative, so 0, f of 0 0.2 in the first range, so 0 0.2, f of 4 will be 1. If you look at f of 2, when we are calculating f of f2 of x, it is f1 of negative x. So instead of minus 4, we'll get 4. So the value here will be 1. Instead of minus 0 0.2, f2 of minus 0 0.2 will be f1 of minus plus 0 0.2. So we'll get this value here, which is 0 0.2. When x is negative, we are getting a positive value. But when x is positive, for example, f2 of 4, this will be equal to f1 of minus 4. So this becomes negative. The values will be 0. So what I'm saying is the values interchange since the sign interchanges. If you look at f3, f3 is nothing but the negative of f2. So we can simply put negative sign in all of these. For example, if we look at f3 of minus 4, f3 of minus 4 is minus f2 of minus 4. f2 of minus 4 was 1, so this will be minus 1. If you look at f4, as f2 and f1 are related, f4 and f3 are related. So the values will invert, and therefore the values will be 0, 0, 0 0.2, minus 0 0.2 and minus 1. Why does this happen? Because f4 of minus 4 will be equal to f3 of 4. f3 of 4 was 0. So f4 of minus 4 will be 0. f4 of 4 will be f3 of minus 4. f3 of minus 4 was minus 1. So f4 of 4 will be minus 1. Question says how many of the following products are necessarily 0 for every x? f1x into f2x. 0, 0, 0, 0. This product is always 0. f2 into f3, not always 0. f2 into f4, 1 into 0, 0.2 into 0, 0 into minus 0.2, 0 into minus, always 0. So two of these three products are always 0, and that becomes my answer. Again, working with x is difficult, but the moment you take the right ranges, we are just calculating values and the question will become a lot easier. Moderate level of difficulty, 2.5 odd minutes to solve the question. F0 and F1 have opposite signs. If one is positive, the other is negative. If one is negative, the other is positive. And therefore, we can say F0 into F1, positive into negative, has to be less than 0. Which of the following is necessarily true? What is F0? Put the value of 0 here. So that will be A. What is F1? Put the value of 1 in X. So 1 minus 5 plus A. This is less than 0. So A into A minus 4 is less than 0. And I think this is pretty straightforward. The critical points will be 0 and 4, plus minus plus, because we're looking at negative. So A lies between 0 and 4, and that is my answer. Easy question, should not take more than 2 minutes to solve, and done. If you look at the overall test, as I was saying, moderate difficulty, trying to get 5 to 6 net correct. Attempt time obviously will be higher for this test, as you would see. My 6 questions would be 1, 3, 6, 8, 9, 10. Which are these? I am doing this because the process is standard. Not counting this one because there is chance of calculation mistake happening. Definitely doing this one, greatest integer function, the expression looks difficult, but once you put the values, it is a lot easier to solve. Not counting this one because arranging the terms in the right form might be a little difficult. Not counting this one either because there are multiple steps involved. This I'm counting as an attempt question because again, all you have to do is put values from the options and get the answer. Counting this one, no, not counting this one. This is a difficult question for me outrightly. This I am counting because we're just making cases, taking M as even and odd, and then solving the quadratic. Counting this one as well because if we have taken we take 4 ranges and then just find the value of the functions to get the answer. And I'm definitely counting this one because in the entire test, this I think was the easiest question. So for me, my 6 attempts would be 1, 3, 6, 8, 9, and 10.